program. Now, to South Africa, where a system of small boxes which use lasers is the latest homegrown invention to measure air pollution across the country. And it uses the power of artificial intelligence to monitor pollution in real time. The project has been led by Professor Bruce Mellado from Witwatersrand University and a senior scientist at Itemba Labs. Professor Mellado joins us now from Geneva. Good morning to you and welcome to Newsday. Just explain to our listeners how these boxes actually work.
First of all, thanks for having me. As you correctly pointed out, this system is composed of sensors which are laser powered and laser driven. Then these sensors send data through Internet of Things technologies. And this data is stored in the cloud and processed with artificial intelligence, which is used to provide reports, provide interpretations, and provide forecast of how bad or good the air quality is going to be in space and time.
And how do then the population or the populace get hold of that data information?
So since we are publicly funded, all this data is publicly available through our website, our dashboard. We are also integrated into the air quality information system of South Africa. And this data can be downloaded by scientists, public, journalists, and so on and so forth.
How huge an issue is air pollution to public health in South Africa, Professor?
So in general, air pollution, at least in the African context, kills more people than TB, malaria, and HIV combined, partially also due to the advances of drugs and treatments for these diseases. So it has emerged as a major public health in Africa and in South Africa in particular. And the problem with air quality is that it's not monitored enough in order to inform policymakers to enact remedial action. And that's where we have come in order to provide affordable solutions that are smart enough and are accurate enough to provide that information.
Are you engaging with the South African authorities and government on how to tackle air pollution in the country?
Yeah, absolutely. We work with different stakeholders, both at the federal level, provincial level, and municipalities. This is an effort that has to be developed in collaboration with government and policymakers, because we really need action to be taken in order to understand where the hotspots are, how to alleviate those, how to prevent them, and how to deal with the sources and remedial action.
What are some of the hot spots that you've noticed with these boxes?
Yeah, that's a very interesting question. We have rolled out already a number of systems in the city of Johannesburg. And once you are on the ground and provide measurements, you'll really realize how complex the picture is and how those hotspots emerge in random locations driven by various sources. So the only way really to spot these hotspots is to really have a dense network of measurements throughout the city. It doesn't work to make theoretical predictions. So without these dense measurements, we can't really determine where those hotspots are. And once we have the history and how these are correlated with weather patterns, then we are able to provide predictions and forecasts.
Professor, thank you so much for your time. Professor Bruce Mellado there from Witwatersrand University.